This presentation is one of 6 on non-destructive testing. The topics covered by the other presentations are Introduction to Non-Destructive Testing, Magnetic Particle Testing, Radiographic Testing, Eddy Current Testing, and Ultrasonic Testing. This presentation is an introduction to penetrant testing. The material is not intended to train individuals to perform NDT functions, but rather to acquaint them with NDT equipment and methods that they are likely to encounter. Knowledge of the basic principles and typical applications should enable them to know when to call for help from experts. Penetrant testing is an extension of visual inspection, in which the detectability of small surface discontinuities is enhanced. We will provide a general introduction, discuss penetrant materials and considerations, cover the basic steps in penetrant testing, show common equipment which is used, discuss the advantages and limitations of penetrant testing, quickly summarize the presentation, and then discuss a glossary of terms. The basic idea of penetrant testing is to use a liquid which is drawn into surface breaking discontinuities by capillary action. The excess liquid is then removed from the surface and methods applied to enhance the visibility of the trapped penetrant. This slide illustrates the effect of capillary action. Liquid is drawn up higher in the smaller diameter tubes because of the surface tension of the liquid. Plants and trees use capillary action to draw water from the ground. The human body uses capillary action to distribute blood to every cell in the body. This slide illustrates the 6 basic steps in a penetrant testing process. First, the test article must be clean and dry. If the surface is dirty or the surface breaking discontinuities filled with fluid or material, the penetrant will not be drawn into the discontinuity. Next, the penetrant is applied. After dwelling for some time to allow the capillary action to occur, the excess penetrant is removed from the surface. A developer is applied to help draw the trapped penetrant out to the surface where it may be more easily detected. The surface is then visually inspected. The final step is to clean the test article after inspection. Almost any material that has a relatively smooth, non-porous surface on which discontinuities or defects are suspected can be inspected. Conversely, test articles with rough or porous surfaces cannot be inspected. The reason is that defect indications become less distinguishable as the background noise level increases. Similarly, articles which absorb or react with the penetrant cannot be inspected. Coatings which prevent penetrant from entering defects also prohibit penetrant inspection. Many types of defects can be detected. The key feature is that the defect must be open to the surface. Some types of defects include cracks, seams, laminations, cold shuts, hot tears, porosity, blowholes, shrinkage, lapse, external bursts, undercut, overlap, lack of fusion, and lack of penetration. The first task when conducting an inspection using PT is to choose the right materials for the job. Each combination of materials has its own advantages and disadvantages, which will be discussed in the following slides. Penetrant materials must possess the following important characteristics: spread easily over the surface being inspected, be drawn into surface breaking defects by capillary action or other mechanisms, remain in the defect but remove easily from the surface of the part, remain fluid through the drying and developing steps so that it can be drawn back to the surface, be highly visible or fluoresce brightly to produce easy to see indications, not be harmful to the inspector or to the material being tested. Penetrants are formulated in various sensitivity levels ranging from low to ultra high. The choice of sensitivity level depends upon the material and the type of defects of interest. The higher the sensitivity, the higher the probability of non-relevant indications. Penetrants are either visible or fluorescent. That is, visible or red dye penetrants are inspected using white light. Fluorescent penetrants are inspected using ultraviolet light in a darkened area. Fluorescent penetrants can be more sensitive than visible penetrants because the eye is more sensitive to a bright indication on a dark background. The visible penetrants are level 1 or low sensitivity. The fluorescent penetrants can range through all 4 sensitivities. Visible penetrant is usually red because red stands out against the white background of the developer. Fluorescent penetrant is green because the eye is most sensitive to this color. Different penetrants are designed to be removed by different methods. They are classified by the method of removal. There are solvent removable, water washable, and post-emulsifiable penetrants. The post-emulsifiable system uses an emulsifier solution to make the penetrant water washable. The emulsifier reacts with the penetrant on the surface, but not in the flaw, thus providing an advantage when there is concern about washing the penetrant out of the defect. The developer pulls the penetrant out of the defect, spreads it out on the surface, and provides increased contrast for visible penetrant. There are 4 types of developers. Dry powder clumps together where the penetrant bleeds back to the surface. Wet, water suspendable powder covers the surface in a relatively uniform layer of developer. Wet, water-soluble powder forms a crystalline layer on the surface after the water evaporates. Wet, non-aqueous is the most sensitive developer and is used for small areas. Just to review, the 6 steps of penetrant testing are pre-clean, apply penetrant, remove excess penetrant, apply developer, inspect, and post-clean. We will discuss each of these steps in more detail. Since the test article must be free of surface contaminants, the cleaning process must remove these contaminants from the surface and the defects without closing any of the surface-connected defects. This is the most important step in the process. Besides contaminants, the defects which normally would be surface breaking can sometimes be closed by metal smearing. If the machining, finishing, or cleaning operations could smear the surface, etching may be needed prior to penetrant inspection. There are many possible methods of applying the penetrant, including brushing, spraying, dipping, immersing, etc. In all cases, the penetrant must be allowed to dwell on the surface for a specified amount of time to allow the penetrant to enter the defects. Depending upon the type of penetrant, the corresponding removal method must be used. For water washable penetrants, a coarse water spray is used to remove the excess penetrant. The water temperature and pressure must be controlled to keep from washing the penetrant out of the defects. Special nozzles are used to create a stream of relatively large drops with low force. The solvent removable penetrants are removed by wiping with a clean, dry cloth, followed by wiping with a cloth lightly dampened with solvent. If a solvent is used, time must be allowed to allow the solvent to evaporate. As mentioned before, if there is concern about removing penetrant from the defect, a post-emulsifiable system is used. This requires using an emulsifier to make the penetrant water washable. As before, the timing of this process is important. The various methods of applying developer will be covered by the following slides. The test article must be dry before applying dry powder. Thus, drying is part of the application process. Dry powder may be applied by immersion, dusting, or placing the article in a dust cloud chamber. Wet developers may be applied while the test article is still wet from the removal process. After the excess liquid drains, the part is then dried. Non-aqueous developer may be used with both visible dye and fluorescent penetrants. The developer is applied by aerosol spray to a thoroughly dry and cool part. The coating should be thin, white, and slightly transparent. There are specified accept-reject criteria used to evaluate the visible indications. The inspector attempts to determine the origin of the indication and judges each indication to be relevant, non-relevant, or false. Of course, the inspection is not complete until the findings are recorded either in writing or by drawings or photographs. Finally, the test article is thoroughly cleaned to remove all penetrant processing materials. Some penetrant materials may be detrimental to further processes or the intended use of the part. Since penetrant inspection is a process, there are several inspection systems to help control the process. There are portable systems and stationary systems. The system performance should be routinely checked using various test panels with known cracks. Penetrant testing has the following advantages. Penetrant testing is relatively easy to use. It can be used on a wide range of material types. Large areas or large volumes of parts or materials can be inspected rapidly and at low cost. Parts with complex geometries are routinely inspected. Indications are produced directly on the surface of the part, providing a visual image of the discontinuity. Initial equipment investment is low. Aerosol cans make equipment very portable. Penetrant testing has the following limitations. Penetrant testing only detects surface breaking defects. It requires relatively smooth, non-porous material. Pre-cleaning is critical. Contaminants can mask defects. Penetrant testing requires multiple operations under controlled conditions. Chemical handling precautions are necessary. Toxicity, fire, waste. Metal smearing from machining, grinding, and other operations inhibits detection. Materials may need to be etched prior to inspection. Post-cleaning is necessary to remove chemicals. In summary, penetrant testing is one of the most widely used NDT methods because it is flexible and relatively easy to use. The downside is that PT requires closely controlled processing steps to achieve optimal sensitivity. The following glossary of terms defines some of the terms used in penetrant testing. Capillary action is the tendency of liquids to travel or climb when exposed to small openings. Contrast is the relative amount of light emitted or reflected between an indication and its background. A defect is a discontinuity that affects the usefulness of a part or specimen. A developer is a finely divided material applied over the surface of a part to help promote reverse capillary action and thus bring out a penetrant indication. A discontinuity is any interruption in the normal physical structure of a part. It may or may not affect the usefulness of a part. Dwell time is the period of time that a penetrant or developer must remain in contact with the surface of a part under test. Emulsification time is the time allowed for the emulsifier to render the penetrant water washable and thus allow the part to be washed. An emulsifier is a material applied over a film of penetrant that renders it water washable. Evaluation is the process of deciding the severity of the condition after an indication has been interpreted. A false indication is an indication caused by improper processing, not caused by a relevant or non-relevant condition. Flash time is the time required for the solvent to evaporate from the surface of a part when used to remove excess penetrant. A fluorescent dye becomes fluorescent, gives off light, when exposed to short wavelength radiation, such as ultraviolet light. An indication is the visible evidence of penetrant bleed out on the surface of the specimen. Interpretation is the process of evaluating an indication to determine the cause and nature of the discontinuity. Non-aqueous developer is a developer in which developing powder is applied as a suspension in a quick-drying solvent. Penetrant is a liquid used in fluorescent or visible dye penetrant inspection to penetrate into the surface openings of parts inspected via these methods. Relevant indication is an indication that has been determined not to be false or non-relevant, an actual discontinuity. Seeability is the characteristic of an indication that enables it to be seen against the adverse conditions of background, outside light, etc. Sensitivity is the ability of a penetrant to detect surface openings. Higher sensitivity indicates smaller discontinuities can be detected. Ultraviolet light, or black light, is light energy just below the visible range of violet light, 356 nanometers. Viscosity is the resistance of a fluid to the motion of its particles. Washability is a property of a penetrant which permits it to be cleaned from the surface of a part by washing with water.